You're listening to the N2K Space Network.
And now a word from our sponsor, SpyCloud, the leader in operationalizing cybercrime analytics. Traditional threat intelligence is a thing of the past. Cyber criminals are stealing vast amounts of credentials, session cookies, and financial data every day, and it's hard to keep up. SpyCloud is the trusted partner businesses turn to fully understand their darknet exposure risk and neutralize threats before it's too late. SpyCloud alerts your organization as soon as an employee or customer's data appears on the darknet, so you can act faster than bad actors to prevent cyber attacks like ransomware, session hijacking, account takeover, and online fraud. With insights from the industry's largest repository of recaptured data, protect the digital identities and systems most important to your business. Get your free corporate darknet exposure report at spycloud.com/cyberwire and see what information criminals have in their hands today. That's spycloud.com/cyberwire.
Humanity's understanding of the moon's origin changed a lot once scientists got to study the rocks that the Apollo missions brought back to Earth. No, the moon probably wasn't formed from a bunch of asteroids that slowly and gently glommed together over time. No, the moon was violently formed from Earth. Our natural satellite is the orbiting reminder that a Mars-sized object once slammed into our planet and took a big chunk off. That's the current theory anyway, based on the moon rocks that we've studied so far, which have all been from the lunar near side. Will that theory hold up to scrutiny once we start studying samples from the lunar far side? Now that Chang'e 6 has returned those samples to Earth, we will soon find out.
T-minus 20 seconds to LOS speed rest. Go for deploy. Roger roll.
Today is June 25th, 2024. I'm Maria Varmazis, and this is T-minus. China's lunar mission capsule returns to Earth. ISRO conducts a third reusable launch vehicle landing experiment. Airbus predicts financial hits to its space division. And our guest today is Ryan Westerdahl, CEO and founder of Turian Space. We'll be discussing how AWS infrastructure has helped the space startup company enhance its mission capabilities. Let's take a look at our intel briefing for this Tuesday. And it's a job well done to the Chang'e 6 mission team, as the mission's capsule containing 2 kilograms of lunar far-side soil samples touched down on Inner Mongolia at 2:07 p.m. Beijing time today, according to Chinese state media CCTV. The lunar soil sample is from the South Pole in the Aitken Basin, and now that they're here on Earth, those samples will be sent for study in Beijing. This is the first time any nation has retrieved samples from the far side of the moon, and China will be the first to help humanity better understand why the lunar far side is so different from the near side, which will in turn help us better understand if our current theories about the moon's formation are correct. It'll be fascinating to hear the scientific research revealed from this mission. In the meantime, congratulations to China on this milestone achievement. The Indian Space Research Organization, better known as ISRO, has successfully conducted the third reusable launch vehicle landing experiment. This mission, known as RLV-LEX-03, was conducted at the Aeronautical Test Range in Chitradurga, Karnataka. The winged vehicle, named Pushpak, was released from an Indian Air Force Chinook helicopter at an altitude of 4.5 kilometers. The Pushpak then autonomously executed cross-range correction maneuvers, approached the runway, and performed a precise horizontal landing. The vehicle is part of ISRO's critical technologies that they plan to use for future orbital re-entry missions. European aerospace manufacturer Airbus lowered its profit guidance for the full year 2024 and said supply chain issues will see it deliver fewer aircraft than it previously expected this year. The aerospace giant said it would be recording a €900 million hit in the first half of its 2024 accounts after new management in its space division carried out an extensive technical review of its programs and identified various commercial and technical challenges. Airbus said those issues in its space division largely relate to schedules, workload, sourcing, risks, and costs over the lifetime of certain telecommunications, navigation, and observation programs. More good news in Virginia. Firefly Aerospace is adding an alpha launch capability at the Mid-Atlantic Regional Spaceport, also known as MARS, on Wallops Island, Virginia. Pad 0A will be configured to launch Firefly's Alpha as early as 2025, in addition to Antares 330 and the medium launch vehicle that the company is co-developing with Northrop Grumman. In addition to the launch pad, Firefly plans to operate a launch control center, horizontal integration facility, and administrative office space on Virginia's eastern shore. And going way up the coast, Canada's Maritime Launch Services has received approval from the province of Nova Scotia for the development of a satellite processing facility as an eligible project for reimbursement under the Capital Investment Tax Credit Program. Maritime Launch has received approval for an initial qualification of up to $7.5 million in reimbursements and plans to begin construction later this year. A collaborative project between Egypt, Kenya, Nigeria, and Uganda, called the African Development Satellite, is on track to be launched at the end of the year, according to the Chief Executive Officer of the Egyptian Space Agency. The African Development Satellite focuses on climate change studies, with the participating African nations jointly designing the satellite's subsystems. Egypt is taking the lead on design, assembly, integration, testing, and launch. Sidus Space has signed a memorandum of understanding outlining its collaboration with Namasys to establish a joint venture in Saudi Arabia. The Namasys and Sidus Space joint mission aims to explore opportunities for sustained access to space for the Gulf Cooperation Council, or GCC, countries through the establishment of satellite manufacturing and space-based data collection. The Malaysian Space Agency is partnering with local company SpaceIn for ground station and IoT development. SpaceIn is developing a ground station in Banting and a ground sensor terminal for IoT applications for Malaysia's Industrial Technology Innovation Center project. The country is hoping to create a hub for innovation to help develop its growing space interests. iSpace US has signed a collaboration agreement with the Swedish Space Corporation for ground station services for iSpace US's upcoming Mission 3 with the Apex 1.0 lunar lander. iSpace US's Mission 3 will provide lunar lander services to Schrödinger Basin on the far side of the moon as part of the Draper-led NASA Commercial Lunar Payload Services program. iSpace US will transport and operate government and commercial payload instruments for lunar surface science for the mission, which is scheduled for 2026. The Swedish Space Corporation, or SSC, will be the sole provider of the commercial communication system that the Apex 1.0 lunar lander will use during its transit to the lunar surface, leveraging 4 SSC Connect deep space ground station sites. And weather permitting, and that is always the catch, isn't it? And should everything go according to schedule, it'll be flight number 10 for a SpaceX Falcon Heavy this evening, with the 5:16 p.m. Eastern Time launch of NOAA's GOES-U weather satellite mission from Pad 39A at Kennedy Space Center. This 5,000-kilo satellite is heading to geostationary orbit, and so its ride to space needs all the power it can get. And as such, the Falcon Heavy's center booster will be fully expended, while the 2 side boosters will return to Earth on drone ships. As with all Falcon Heavy launches, this should be quite a show. Fingers crossed for good weather. And that concludes our briefing for today. We've added 3 additional stories in the selected reading section of our show notes that we think you'll enjoy. One's on pooping on the moon, because, we all gotta go sometime. And another's on AST Space Mobile leadership, and a third's on Mynaric's new contract with Reorbit. But yeah, I have a feeling you're all gonna run and not walk to the pooping on the moon story. Hey, T-Minus crew, if you're just joining us, be sure to follow T-Minus Space Daily in your favorite podcast app. And also do us a favor, share the show with your friends and coworkers. Here's a little challenge for you. By Friday, please show 3 friends or coworkers the podcast. That's because a growing audience is the most important thing for us, and we would really love your help as part of the T-Minus crew. So if you find T-Minus useful, please share it so other professionals like you can find the show. Thank you for your support, everybody. It means a lot to me and all of us here at T-Minus.
The IT world used to be simpler. You only had to secure and manage environments that you controlled. Then came new technologies and new ways to work. Now, employees, apps, and networks are everywhere. This means poor visibility, security gaps, and added risk. That's why Cloudflare created the first-ever connectivity cloud. Visit cloudflare.com to protect your business everywhere you do business.
Our guest today is AWS Aerospace and Satellite customer Ryan Westerdahl, CEO and founder of Turion Space.
I'm Ryan Westerdahl, the CEO and one of the founders of Turion Space. At Turion, we are building and operating droid satellites, and we aim to unleash the potential of Earth orbit. So I'll get into what that means in a minute, but I'll first tell you a little bit about my story. What really got me into the space industry in the first place, like a lot in this industry, as a young kid, was just obsessed with space. Specifically learning about planets around other stars and making it my life mission to build the ships that go there. Reality check, it's not going to happen anytime soon. So what's the next best thing? Probably got to go to Mars. Who's doing that? SpaceX. So that's where I was like, I got to get to SpaceX. So went to University of Washington, majored in aerospace engineering. That's where I met my co-founder, Tyler Pierce. And through some internships, at Aerojet Rocketdyne, working in some of the labs on campus in the fusion department, I got to SpaceX and was there for 9 years as a propulsion dynamicist was my role. Biased opinion, the most interesting role at the company. There was only a few of us, and we were kind of the team that when things blew up, you would call us to help piece the data together to figure out what happened and how to prevent it from happening again. So really got to work with a lot of different teams and kind of from a bigger picture, but also getting down into the nitty-gritty technical details of things. So it was a great time. And the thing I love the most is it's hardcore. And at Turion, that is the top principle, hardcore engineering. Turion really started when I was at SpaceX, looking at always kind of having the itch. Even though I was at my dream job, I always had the itch with bringing the cost of launch down so much. What's next? Working on things like solving orbital debris became really an important problem for us. So got my co-founders together. One thing led to another. We got into Y Combinator, and from there, it's been off to the races. And that was about 3 years ago. So yeah, and really one of the enablers for Turion, not just the obvious one is the lower cost launch from Falcon 9 reuse and all that, but just as important, maybe even more important, one of the other enablers for companies like us to even exist is actually AWS ground stations. Not having to own and operate our own ground stations saves a ton on logistics, CapEx, I mean, you name it. So it's really one of the other pieces to the puzzle that allows a company like us to actually execute our mission. Besides that, on the AWS note, since we're talking about it, all of our cloud infrastructure and what we're building on from the mission control system to the mission planning and the user-facing APIs and applications, all of that is hosted on AWS Cloud. So we are hardcore users, I would say.
As you said, those pieces of the puzzle are really coming together. The place where we are in time in space exploration, where technology and cloud is right now, enabling companies like yours to accelerate so quickly. And as you mentioned, like that, the existential issue that is orbital debris. I mean, that is such a huge problem. I feel like this is a good opportunity for us to take a look at what Turion is doing. So I'd love for you to tell me more about the company. Give me a pitch and tell me about the cool stuff you're working on.
Absolutely. That's my favorite part. With Turion, what we believe is the space industry is only a fraction of what it must become. And with our goal of unleashing the potential of Earth orbit, we're going to build products and services to address some of the key bottlenecks. And, the first one that I mentioned, orbital debris, obviously is critical to the sustainability of the future of Earth orbit and a healthy commercial space economy. Without that in place, if there's no viable commercial space industry, space technology advancement will stagnate and we'll be waiting around for some rock to take us out. So we don't want that. That was really how we started the company and what we're focused on. But with orbital debris, it's a questionable market as far as it currently exists now, and the regulatory environment is still kind of uncertain and unclear. But with actually doing things like orbital debris, there's another piece to the puzzle that you actually need to figure out, and that's just looking at space objects, doing non-Earth imaging. So really what our more near-term focus on is helping address some of the key national security threats and gaps in the space industry and doing space-based non-Earth imaging, taking pictures of other satellites and doing things like rendezvous and proximity operations and space situational awareness. And when I say like flyby imaging and non-Earth imaging, like this isn't just like a point of light that you can do from ground-based optical systems and radar, which does a really good job. In fact, those companies are partners to us, not folks we would compete with, but really like we get image an object and you could see features of that specific spacecraft. I think you could probably connect the dots on what that might mean from a national security perspective, but understanding what other people are doing is a necessity towards and a precursor to whatever comes next. And yeah, with our Droid 1 satellite, it was our first satellite. It's been in operation now for 1 year, and it took us some time, but we're fully operational doing non-Earth imaging missions now for our customers. So it's a really exciting time. And I will say, like, one thing we haven't announced publicly, so I'll just throw it in on this podcast, is we have successfully got our first non-Earth images. Some of those we plan to share, some of those we do not. So it's a really exciting time at Turion.
Congratulations. That's huge. That's really awesome. I'm imagining the incredible technical challenge of acquiring that kind of imagery. The motion of things involved, the distances, just being able to pinpoint. What a fascinating problem that must be to unravel. So like that's got to be fun and really, really challenging, but fun.
Absolutely. And like I said, one of the core principles of Turion is hardcore engineering, and that comes from the top. Tyler and I are very technical founders, I would say. Now we're also heavily involved in different parts of building out the strategy, near term, long term. So really exciting time. We just moved into a new facility where by 2027, we'll have scaled to the production line to be able to do 45 satellites a year. And we're building the next one right now.
That's incredible. You need to be focusing on those incredible technical challenges, not so much the infrastructure that's backing it up. Like it needs to be there, it needs to be secure, it needs to be solid, but that you don't want to also have to spend a lot more time than you need to focusing on that. So it sounds like that's also where AWS can kind of maybe alleviate some of that and just let you all focus on what you want to be doing.
Yeah, not having to build our own cloud infrastructure definitely is nice. So that's kind of like the core bottlenecks that we see to unleashing Earth orbit. Those are the obvious ones, I'll say. I think the least obvious one, and this kind of segues into another thing I would want to talk about, is, well, one thing we've learned from Droid 1, like to our core, is the misalignment of incentives across the satellite industry. And specifically what I mean by that is, let's say you're a satellite maker and you give satellites to other companies. The biggest problem with that is, in terms of having aligned incentives with your customers, is if you deliver a satellite, even if your documentation, your ICD is perfect, they're still going to have 1,000 questions on how to actually operate it, because operating the satellite is so intimately tied to the flight software and the design of the satellite. So one other thing we are doing is also addressing that kind of bottleneck and that misaligned incentive structure. So another thing we're doing is also hosting payloads on our satellites. And we're doing this a little bit different than a lot of other companies because we can give, I think, the best deal in the industry on a dollar per capability perspective, because with spare capacity on the satellite from a volume and just from a operations perspective, we're going to fill it up with some of our other payloads and our partner company payloads. And because of that, we can really give a good deal on how much it actually costs to host the payload and get to orbit. And we'll manage all the day-to-day operations and just provide the most simple experience that you can imagine for controlling what your payload might be doing. Just a series of tasking APIs and user interfaces. So that is really a big one, I think, in the industry that took us a long time to really understand. And the reason why we decided to do it is because putting satellites up in space for doing non-Earth imaging, space domain awareness, and eventually debris removal is not necessarily super cheap. We're pretty vertically integrated, so our unit cost is really good, but that doesn't mean it's cheap. And so by hosting other people's payloads and putting our extra payloads on those satellites, this effectively, by putting more satellites up, we can accelerate the rate at which we're putting data collection nodes in orbit. And that's how we're really going to capture kind of this first S-curve in the story arc of Turion space.
Wow. Okay, so I have to wonder about like the cybersecurity, how that is involved in all these operations, especially with hosted payloads now in the mix as well. That's got to be a major concern given what you all are working on.
Most definitely. So from the telemetry and the command and control stuff that's going up to the satellite, all of that is encrypted end to end. So it's definitely something that we take seriously. In fact, a recent White House national security cyber paper that was published from the White House talks about cyber and a pretty good section about the space industry and what can be done to increase security. And one of those things, like one of the main tenets of that, which we agree with, is memory safe software development. So using languages like Rust that are memory safe inherently is one of the medium kind of term initiatives that we are executing so that we really have the best when it comes not only to just the satellite itself, but also from a cybersecurity perspective. And, would be great to just announce kind of like some of those products that people can go out and look. By the time this podcast is released, if you check out our website, you can take a look at what your options are for hosting payloads. And we're announcing our Droid Alpha family of vehicles, Droid Alpha Mini, Droid Alpha, and then Droid Alpha Enhanced Mobility. So another thing that we're going to be a little bit different from some other providers out there is we are not going to be configurable and have 20 options for every satellite. You're going to have those 3 options, and that's what we're building. Use it or don't. That means we may walk away from deals, but that's okay because that's not the primary business. We just want to host some payloads to accelerate the rate at which we put these up and build really strong customer relationships with a handful of people rather than everyone. So Droid Alpha Mini, that one's flying here pretty soon on Droid 2. And that is like the same vehicle bus architecture across our series of Droid Alphas. So Droid Alpha is, up to 300 kg satellite, and Droid Alpha Enhanced Mobility is a little bit bigger, and it has our propulsion system integrated. Our propulsion system is a gridded ion thruster, which is counter to the mainstream, I would say, narrative when it comes to electric propulsion, which has really gone with Hall thrusters. And there's been some arguments why Hall thrusters are more preferable. Gridded ion thrusters are more complex. They can be far more efficient from a fuel efficiency and ISP perspective. But Hall effect thrusters are simpler and have higher thrust to power. So with electric propulsion, you're talking tens to hundreds of millinewtons of thrust. It's really low thrust, but it's really efficient. So Hall thrusters typically have like twice the thrust to power. But with some breakthrough technologies we're incorporating, we've actually addressed that with this gridded ion thruster architecture, and we'll be at comparable thrust to power. So the propulsion system is something we're stoked about, and we'll be integrating onto our Droid Enhanced Mobility vehicle. So those 3 vehicles, flight ready in 12 months, 18 months, and 24 months respectively. Give us a call if you want to fly.
Fantastic. And it sounds like secure by design as well, which is always great to hear. So you've touched on so many incredible things that you all are working on right now, things that are in the near term. What is your company's long-term vision?
Our long-term vision is really to solve orbital debris and build a multi-billion-dollar company in the process. But the long-term vision of Turion Space is to go extend beyond just Earth orbit and really unleash the potential and unleash mankind's galactic destiny. And what does that actually mean? How do we become a galactic civilization? I think it really needs to be economically driven. And what we are making a bet on is that platinum group metal asteroid mining is going to be that thing. We're going to learn a lot from some of the NASA missions going on right now, like Psyche, but platinum group metals from asteroids is a potential $1 trillion industry if it can be done. But what we also believe to our core is that it is going to take a lot of time, and it is going to take billions of dollars to actually do it scale. And without doing it at scale, it's kind of a moot point. So our strategy is to build the technical and the financial foundation, solving critical bottlenecks in the current Earth orbit industry, and use that as the catalyst for being the company that's going to be most well-positioned to go after platinum group metal asteroid mining. So that is the long-term vision of Turion.
We'll be right back.
Attention all security professionals. Want real-time IP intelligence at your fingertips? Sign up for Scout Insight's free trial today. Get immediate insights into threats, search any IP with no training required, and enjoy intuitive graphical results. Whether you need to identify compromised hosts or enrich Splunk queries, Scout Insight has you covered. Don't wait. Accelerate your threat response now. Visit teamcumry.com/cyberwire to start your free trial.
Welcome back. Last year, when news that Virgin Orbit was in its last days, there were chitterings that someone, maybe some deep-pocketed space fan, might buy up the company at bargain bin prices. That is not what happened. Virgin Orbit is sadly no more, and it has literally been sold for parts at this point. But if you were following the story last year, when Virgin Orbit's fate still seemed a bit iffy, you might remember some news about a mystery space industry investor, a heretofore unknown from Texas, who just happened to have $200 million to buy up Virgin Orbit, a seemingly golden ticket for the company. And news of the Savior investment offer also sent the Virgin Orbit stock up 33.1%. This investor, a Matthew Brown of Texas, even had his 15 minutes of fame in an interview as the front-running prospective buyer on CNBC. And it had a lot of people basically going, wait, who is this guy? Well, that skepticism was warranted. Matthew Brown was not some last-minute cowboy investor coming to save Virgin Orbit. The SEC says, actually, he was all hat and no cattle. He didn't have $200 million to invest. He didn't have even $2 million. He didn't even have $1. The SEC says he actually had a negative net worth. He photoshopped a screenshot of his company's bank account to show a fake $182 million balance, and then also completely ignored any basic due diligence inquiries from Virgin Orbit as well, allegedly. Well, now Mr. Brown is in trouble with the SEC, which has filed a formal complaint against him, not only with punitive monetary penalties, but also it's seeking a permanent injunction against him from holding any kind of officer or director role at a company ever again. Matthew Brown, we should note, denies all of the SEC's allegations, calling them, quote, fictitious, inaccurate, and exaggerated. In the meantime, let all of this serve as a warning to anyone else thinking of trying to swagger their way into buying a space company. Maybe have more than $1 in your bank account. That's it for T-Minus for June 25th, 2024, brought to you by N2K Cyberwire. For additional resources from today's report, check out our show notes at space.n2k.com. We're privileged that N2K and podcasts like T-Minus are part of the daily routine of many of the most influential leaders and operators in the public and private sector, from the Fortune 500 to many of the world's preeminent intelligence and law enforcement agencies. This episode was produced by Alice Carruth. Our associate producer is Liz Stokes. We are mixed by Elliot Peltzman and Trey Hester, with original music by Elliot Peltzman. Our executive producer is Jennifer Iben. Our executive editor is Brandon Karpf. Simone Petrella is our president. Peter Kilpie is our publisher. And I'm your host, Maria Varmazes. Thanks for listening. We'll see you tomorrow.